Hey, how's it going? It's Jack Lyon here today for my first Patreon tutorial. Some of you may be familiar with this one from the YouTube channel, but I wanted to make a more concise video where I go a little more in depth on some of the things that are going on in the patch and show you how to make your own sort of modifications to the input. So let's just jump right into it. First, I would like to show you what our end goal is today. So, of course, we can control any parameter we want in live already, but let's say we created a max device in which we wanted to send some kind of signal around somewhere in live for mapping. Like, let's say we create a system within max that does something that we think would be interesting to apply somewhere. So you see it in like the LFO and stuff like that, in the max for live LFO, that is. But in our case, we're just going to start out by building a basic map button. And so as you can see, if I map that to a parameter, the name shows up here, and we can begin to make changes to that, like the range, for example. So, and of course, we can unmap it. The name disappears and the mapping ceases so that we can map it to another parameter. All right, so that's basically what we're going for here. And to get started, we'll have to create a new patch. So I will delete this one and make a max audio effect. All right, so I'm going to split my screen for this. Open this up here. All right, so now what we have is our window for max patching. So I will proceed by first deleting some of these comments. So we have just this plug in and plug out. Now we're gonna just keep that and set it to the side here. And in the meantime, I'm gonna create this panel. So this is where I would say it's safe to maybe make your own device, like your own sort of algorithm for controlling the mapping. So let me show you what I mean. This will be a sloppy example, so do not fault me, please. But if we were to create a node in, divide it by floating point, so that we get a value between 0 and 1, because MIDI goes from, I think, 1 to 127, or something close to that. Make a message box that carries that value, and also sends a message to the line object. So yeah, this is just like a basic example of a nice little algorithm we can create that we can use to control something within our mapper. So another thing you could do would be like to create a cycle object, make it like a LFO sort of, and then make that go between 0 and 1 with this scale object. So let's say like we didn't normalize our value yet. We can just take our input range, which I think is already 0 to 1, and remap it. So like, let's say the range was still like 1 to 127. I can make this like 1 to 127, and everything in between those values will be remapped to a normalized value between 0 and 1. So let me just delete this cycle. All right, so everything below this panel is where the patch is actually going to start. Okay, so let's put this here for now. All right, so first thing we're gonna need is a live.numbox, and I'm just gonna name this like amount or something. Put in the long name, short name, scripting name, and our range is gonna be 0 to 1. We want to change our unit style to float as well. Okay, so now we have a number box that goes between 0 and 1. So now what we're going to want to do is create another numbox, but for this one, we want the unit to be a %. So we'll change that to %. See, %. And then I'm going to make this have a range between 0 and 1. And I forgot to initialize this one. So just for posterity, we're just going to keep this one at 0. And then this one is going to also be at 0. All right, so now we can duplicate this one. And the way I'm doing that, by the way, on Mac, you can hold Option and click to drag to make a duplicate of an object, or you could just hit Command C, Command V. I know on Windows the commands are a little different, so you'll have to forgive me. I believe it's Alt. I'm not sure though. Shouldn't be too difficult to figure out. So on this other one, all we're gonna really change is we're gonna change this to 100%, and we're gonna name this one on the left min for minimum, and this one's gonna be max for maximum. Cool. So we have 0 and 100. So the next thing we're gonna need is a live.text. Move these over. And this live.text, we're gonna make this the mapping button. So we're gonna come over here, long name map, short name map, scripting name map, and let's see. We'll just put the labels as map and leave it on toggle mode. I believe that's correct. Yeah. So the next thing we're gonna do is create a live.text again. But this time what we're gonna do is come over to the mode and select button. And for the text off label, we're just gonna do X, X for everything. And then for the names, just unmap. Oops. What? Oh, okay. So yeah, unmap. And then I'm just gonna shape this so that's like a little nice circle. All right. So next thing we're gonna need is just a simple comment box. So we'll move that right up here. All right. So far so good. All right. So this is gonna be our sort of UI parameters here, and we're to add that to our presentation. We're actually gonna highlight them all, right click, and select add to presentation. So now whenever we go into presentation mode, our objects will appear in the patch. Another thing you might want to do now is select anywhere in the patch where it's empty. Select this, which is going to bring up the inspector for the whole patcher. And we're going to scroll down until we find open in presentation. Okay. And we're going to select that. All right. So that's going to make it so that when we save our device, it's going to appear down here. All right. Moving forward. Now we're going to create the main patch, like for real this time. So we're going to create pmap and create 5 inlets. All right, so first of all, I'm going to go ahead and hook these up over here. So we get our input value. We have our minimum value, our maximum value. Well, these are more like a scalar, but anyway, like a scaling value. So, and then we're going to input our mapping buttons messages into here, as well as our unmap messages into here. All right, so the next thing, here we're gonna have to plug this up into here, the left outlet, or sorry, right outlet into the comment box, and the left outlet back into the map button. Okay, so back to the map patch. What we're gonna do here is convert our scaling value, our minimum and maximum percent, to a normalized sort of floating point value. So to do that, we got to divide by 100 in a floating point way, or fashion, I guess. Don't know how you would say. And we're going to need this trigger bang float. All right, so this is going to make sure that whenever we update this value, that the entire patch sends a message along that updates the value at the end. Basically, when we change the minimum and maximum value, that it actually makes changes to the patch. And you'll see what I mean in a minute. I'll delve more into that with the scale object. So let's say we didn't have a normalized value coming in. We could scale that again here. But the real reason I'm using this inside the patch is, well, first of all, we're going to hook up our first inlet to, well, the first inlet in the patch to the inlet of the scale. And we're going to next look for where it says low output value. So we're going to hook that into here, because remember, this is the minimum. Change that to white. Yeah, so this is the minimum. and this is the max. Okay, so sorry, I didn't mean to plug this into here. This is the bang. So see, it says order 2. That means the bang is going to come after this one, order 1, which is the float. So we actually want to plug the float into the low output value and the float from our max into the high output value. All right. And then the bangs from these TBF objects can go into here. That's because this is the hot inlet. See where it's see that is red? That means that this is the one that will update the object and tell it to send out its message once it receives a message. The blue ones are cold, meaning they will not trigger this object to send out the message. So in order to do that, we first must send the float value we wish to fill in, and then from there, we can tell it to bang the object and it'll send out the message and everything will work nice and clean. So just to reiterate, this low output, high output value is going to take a float from the min and max, and it's going to basically change what these values are. It's going to change the argument, so to speak. All right, so the next thing we need is, this is sort of a special one. We're going to use the M4L .api.device parameter remote. Now what this object does is, if you can't open up a help menu, but if you double tap with command, or on Windows I think it's control, then you see a little description. This patch represents the device parameter. So this object basically will communicate with a device parameter in live, and it'll help you do things to it basically. So without having to think about all of this, how that works, we can just go ahead and start working with the parameter itself. So you see this live remote, live object. These are the live objects that are allowing us to reach into live and do things. And these other objects are sort of supporting the patch to give it the functionality that we're looking for here. So we're going to discover a few more of these, but first, we're just going to keep on patching. So hooking up the output of our scale into the M4L device parameter remote will send our value to said parameter. So the next thing we have to do is finish the patch so that not only will we be able to select what parameter, but also make sure that we don't do things like map to ourselves or just basically make sure it's a clean process and the name of the parameter is displayed, and make sure everything looks nice. So the next thing we're going to focus on is over here. We need a message saying ID 0, hook it up there, and a message saying set. All right, so set also goes to 5 here, and set is going to go to outlet 2. And then ID 0 is going to go to the rightmost inlet of this device parameter remote object. Okay, so the next thing we're going to do is I'm going to create a patcher map. So patcher is the same thing as P. It's just a sub patcher. Doesn't make a difference. And I'm going to create some inlets and outlet, just one. So that goes in there. All right, so the patcher map is going to get plugged in over here to the rightmost inlet of the device parameter remote. And we're going to create a message box with the argument 0. Hook that up to the patcher map, and then send this out of 1. All right, but we're not finished yet. The next thing we're going to do is create m4l.api.getParameterNames. Okay, so what this one's going to do is, well, it says we'll take a list of parameter IDs as an input and generate 2 lists of parameter names. One with a special format and one that is ready for, I guess, like a U menu of sorts. So this is going to basically get the name from what we select. So we still have to set some things up in the patcher map here, but we're going to hook that up anyway now. And then we're going to go over here, type in m4l.api.saveString. Okay, so once it gets the ID, which is whatever parameter name we want, it's going to save that as a string. And then we will prepend the message set, or we will prepend the message set to the string. Okay, so we input the string and the parameter name here. So this is the list, and this is going to save the string. All right, so now what we're going to do is hook that up into outlet 2 here. Cool. So believe that this section of the patch is finished. So yeah, basically this over here is just controlling things having to do with the name, and it's going out of outlet 2 because, as you can see here, outlet 2 goes into the comment box. So whenever we get the name of a parameter, I believe it's going to come in through here. Yeah, through 4. So our mapping button is going to allow us to select a parameter. It's going to send the name of that into here and send it out into the message box, or into the comment box. And then when we unmap something with 5 here, it's going to basically just erase whatever is in there. Okay, so now the next step would be to start patching the patcher map. Okay, so this is going to look at the current set and select the parameter once the button is clicked. And the way we do that is by instantiating the live.path object with the arguments live_set view, and then selected underscore parameter. All right, so that's going to go up here, and first we're going to create a toggle here before we hook those both up to a gate. So the toggle goes into the cold inlet, and the middle outlet of the live path object goes into the gate. So far, so good. So next we're going to use a defer low. This is basically going to, I think what this is going to do is basically delay the priority of this message, because we don't want the process of clicking on map and mapping a parameter to interrupt anything going on with the audio effect or anything in live. We want it to take a low priority so it doesn't interrupt our flow, basically. And then this substitute object, I'm going to be honest, I'm not really sure what this is doing, but it was in the patch when I learned it, and I'm assuming it might be important for some reason. So I would use it, but if you figure out, you know, you don't need it, then by all means, go ahead and please let me know, because I'm curious. But in the meantime, we're going to finish this up here by hooking up a gate with the message, or with the argument 1 after, and another patcher. So this one's going to be p don't map to self. All right, and we're going to need another inlet and another outlet. Okay, so to finish up what's going on here is we're going to hook this up over here. And then this one's going to go over here and out from here. All right, so now we can work on the don't map to self patch. All right, so in this patch, we're going to use a TBL to bang and send a list. So we're going to bang the get path message after we send our list to a live.object and hook them up like so. Okay, cool. So before we move further with this patch, let's select a live.path object. And then this is going to be live_set view this underscore device. So it's telling it to look at the set, look at the view of this device that we're selecting. And then what we're going to do is create another pair like this. This bang is also going to go into the get path here, which is going to trigger the live object to get the path after it's fed this list. So now what we do, well, also we wanted to bang this message whenever it sends out the list here. So next, oh, wait. Yeah, sorry, we're good. So moving forward, we're going to do this. We're going to use a Z Eccles 2, which is just, I believe it's slice backwards. I think there's a ZL Eclipse 2 as well, so do not confuse the two. Because that is a valid object, and they are not the same. So make sure you're using ZL Eccles 2 and connect the live object to it. Select the output from this live.object and insert it into, oh wait, sorry, first before we do that, we need another ZL object. This one's going to be ZL compare. So basically what's going on is we're looking at, hey, are we looking at this at the same device that is the mapping device? And if so, it's not going to allow us to map to it. It's going to open and close gates to prevent us from doing such a thing. So this is getting the path, and I think this is getting the path of itself, and then saying like, if they're the same, then we're going to output this kind of logic where we use the cell, which outputs a bang based off the input matching. So I'm assuming that if it's saying like, hey, it's the same device, it's going to send out a different output. So in this case, I think the T0 would probably be saying like, trigger the message 0 if they compare and they're the same, or 1 if not. And then if it's 1, I think it'll open a gate and allow you to actually make the connection with the map. So if this is all going over your head, like, don't worry about it. We're just trying to build the thing. If you feel like listening and understanding how it's working and what's going on, then good for you. And may the best luck happen to you. I don't know. Anyway, so moving forward, I think we finished the patch. So let's go ahead and save it. We'll call it basic mapper M4L. All right, and save that. I'll save that to my desktop for now. And so, oh yeah, sorry, one more thing. If you did in fact want this, or like if you had like a network, so to speak, or a patch with something that you were using as a control signal for the mapper, whatever it is, you just hook it up to the number object here, or you can bypass the number entirely and send it into the patch. So this won't be necessary for us because we're just building the basic mapper, and then we're gonna I'm gonna actually introduce you guys to some things that you can do with the mapper in the next couple of episodes as we build a macro for Macs. And I'll explain why we're doing a macro next time, but for now, let's focus back on this project. Let's see now if it'll work. First off, I want to check. Yeah, so in order to make it accessible to us in live, we have to create our UI, and I'm going to come over here, go to view, set device width, and then open this up a little bit to reveal this bracket. So I'm going to close it up, save it, and quit down. All right. So now what we should have is a map button that works. So if you change the range, you see it updates the parameter here. That's what the TBF was for. And if you want to unmap, simply click the X button. So yeah, that should do it for now. That's your basic mapping button. And now you can take that and start patching yourself and mapping your own devices around in live. So I hope this was helpful to somebody, and I cannot wait to share more with you guys. In the meantime, take care. Hello guys, I'm back again, and I just wanted to make a small amendment to the video. So somebody pointed out to me that the patch was not working properly when saving live sets, and I figured out why. This silly me, I was just basically, I meant for the original video to be intended as an example of how to make the map button, but then I realized, you know, I want this to be something that people can just use off the rip and be highly optimized so that everything else can work smoothly. I don't want you guys to have to worry about what's going on here. If there's any more updates in the future, I will let you guys know. But for now, this is what we're gonna do: is drop a load bang and live.this device into the project and link those up. And we're gonna send this into a deferlo object, and this device also into each parameter here. Everything except the comment box and the mapping or the unmap button right here. Okay, so just so you can see, we're going out live.this device into the deferlo and the UI objects, and from the deferlo we're going into this parameter. So what's going on is we're sending the saved parameters from the saved live set, and then we're banging this so that that parameter gets sent to the live the live parameter, and that value is remembered. Okay, that way we don't have to jiggle any knobs or anything to get it to trigger. And lastly, what we have here, sorry, not that, this trigger bang defer low over here. This is just sending out a bang every time you click to map to something. So once something is mapped to the device, then it'll bang this once again. And what that'll do is basically trigger the device to install that parameter value right away, so that you don't have to jiggle any knobs to get the thing to start working. So now we're good. This should be highly optimized off the rip for you guys. So I hope this works for y'all. And if there's any more concerns, please don't hesitate to write to me and let me know. All right, see ya.